Okay, so part two of the lesson on complex numbers discusses how to divide complex numbers. So in the previous lesson, remember we added complex numbers, we subtracted complex numbers, and we multiplied complex numbers. Now we're going to talk about dividing complex numbers. And before we do that, let's review this concept from a previous course. So remember when we had something like 6 divided by 2 minus the square root of 3? And you were told to rationalize the denominator. So the directions had said rationalize the denominator. And remember, in the word rationalize is the word rational. So basically, remember, the square root of 3 is an irrational number. So 2 minus the square root of 3 is also an irrational number. That's an irrational number. And the goal was to make the denominator a rational number. And so remember what you did was you multiplied numerator and denominator by the, remember the word conjugate, so you multiplied numerator and denominator by the conjugate of the denominator. And so the conjugate of 2 minus the square root of 3 is 2 plus the square root of 3. So basically you just change the sign of the middle sign. So the denominator here is 2 minus the square root of 3. So you multiplied numerator and denominator by the conjugate. So the conjugate of 2 minus the square root of 3 is 2 plus the square root of 3. All right, so what you do to the denominator, you do to the numerator. And so notice that 2 plus the square root of 3 divided by 2 plus the square root of 3 is still 1. 1 times this is still the original problem. So you're just writing equivalent expression. All right, so the numerator, you have 6. Remember, to multiply fractions, you're going to multiply numerators together, multiply the denominators together. So the numerator, though, you have a monomial times a binomial. So you're saying 6, you're going to distribute. So you're basically saying 6 times 2 plus the square root of 3 divided by, and then this is 2 minus the square root of 3 times 2 plus the square root of 3. And so in the numerator, you're going to distribute. And so I get 12 plus 6 square root of 3. And in the denominator, you have two binomials, so you can use the FOIL method. Now remember what happened when you multiplied the conjugates. When you multiplied conjugates, remember what happened? So you have 2 minus the square root of 3 times 2 plus the square root of 3. So I'm going to use the FOIL method, and then you're going to see what happened. So the FOIL, first times first, so 2 times 2 is 4. The outer is 2 square root of 3. The inner is a negative 2 square root of 3. And now you'll remember what happened. Remember, these are conjugates. The only difference between these two binomials is that sign. One's negative, one's positive. The first terms are alike. The second terms are alike, except for the signs of the second term. They're opposites. And so what happened is that a positive 2 square root of 3 and a negative 2 square root of 3 is 0 when you add them up. All right, now the last, remember this is first, outer, inner. Let's do the last. First of all, a negative times a positive is a negative, and the square root of 3 times square root of 3 is just 3. And so you ended up with 4 minus 3, which is 1. And so notice I went from an irrational number to a rational number. And so we rationalized the denominator, and then we simplified. 12 plus 6 square root of 3 divided by 1 is just 12 plus 6 square root of 3. All right, so that was a review from a previous course. Now let's look at at examples in which we're dividing complex numbers. So let's suppose we had this. So the directions will say divide, or it could say perform the indicated operations. So it could be any one of these. All right, now, let's suppose we had this example. Number 1. Suppose we had 5 divided by 2 plus 3i. All right, so 5 divided by 2 plus 3i. Okay, so remember the idea here, where we multiply the numerator down by the conjugate, will be the same idea here. So remember, I is the square root of a negative 1. Now that's not a real number. 2 minus the square root of 3 is a real number, but remember, the square root of a negative 1 is not a real number. The square root of a negative 1 is undefined, but we represent it as an imaginary number. What you want to do, though, is not have an imaginary number in the denominator. You want the denominator to be a real number. So the goal of dividing complex numbers, the goal here is to have a real number in the denominator. So that's the goal of dividing complex numbers. So just like before, when I wanted to make this denominator rational, I multiplied numerator and the denominator by the conjugate. All right, now remember, the denominator here is a complex number. So 2 plus 3i is a complex number. And so all right, so that's a complex number, just like 5 is a complex number. But remember, I want to make this a real number. So there's something called, just like with this right here, where we multiplied by the conjugate. So the conjugate of 2 minus the square root of 3 is 2 plus the square root of 3. The same idea here. The conjugate of 2 plus 3i is 2 minus 3i. So the conjugate of 2 plus 3i is 2 minus 3i. Now, again, make sure, since we're dealing with complex numbers, that it's in standard form. So it's in standard form. So now we just take change the sign of the operation here. So that becomes 2 minus 3i. So sometimes you'll hear this. You'll hear that the complex conjugate. So instead of just saying conjugate, sometimes you'll hear the words complex conjugate. So the complex conjugate of a plus bi is a minus bi. All right? So going back over here, I'm going to rewrite this over. So I have 5 divided by 2 plus 3i. All right, so I want to make this a real number. That's the goal. So remember, the goal of dividing complex numbers is to have a real number in the denominator. This is not a real number because of that imaginary unit. So I'm going to multiply the numerator and the denominator by the complex conjugate, by the conjugate of 2 plus 3i. So the conjugate of 2 plus 3i is 2 minus 3i. So I multiply both numerator and denominator by that. Now, just like we did this one in a previous course, when you multiply fractions, you multiply numerators together and you multiply the denominators together. So what I'm going to do next is I'm going to rewrite this as 5 times 2 minus 3i divided by 2 plus 3i times 2 minus 3i. All right, and so in the numerator, I'm going to distribute now. So that becomes 10 minus 15i. All right, now the denominator, I'm multiplying two binomials, so I'm using the FOIL method. So we get 2 times 2 is 4. The outer is a negative 6i. The inner is a positive 6i. And before we go on, remember, when you multiply conjugates, notice what happened. The outer and the inner cancel out. When you add them up, they get 0. We get 0. So again, these are conjugates. So when I do the outer and the inner, they're going to be opposites of each other. So that way when I add them up, I'm going to get 0. Now don't forget, there's the last now when we're doing FOIL. So there's my first, outer, inner, and then last. So the last, 3i times a negative 3i. So 3 times a negative 3 is a negative 9, and then I times I is I squared. So don't forget that. You're going to have an I squared somewhere in the denominator. And so I get, let me go ahead and just write this. So see where I had that 4 minus 9i squared? 4 minus 9i squared. So you may want to just kind of do the work here on the side. So I squared, remember, is negative 1. So remember, I squared equals negative 1. So I get 4 minus 9 times negative 1. So a negative 9 times a negative 1 is a positive 9. So that's 4 plus 9. And then 4 plus 9 is 13. So that becomes 10 minus 15i divided by 13. Okay, now, so notice now my denominator is a real number. It's a real number. Now, remember, they want you to write this in standard form. So the directions will say write in standard form. This is not standard form. Remember, standard form is a plus bi. So a, remember, is 10 divided by 13. Minus, and then 15i divided by 13. So that's standard form. Okay, so 10 divided by 13 minus 15i divided by 13. Okay, so if it says write in standard form, and they will, it's got to be a plus bi. So a is 10 divided by 13, and b is a negative 15 divided by 13. All right, so let's look at number 2. So number 2, let's suppose we had 6i divided by 2 plus, let's say 2 minus 5i. So 6i divided by 2 minus 5i. Okay, well, again, I want a real number in the denominator. So I have this imaginary unit. So I got to multiply both numerator and denominator by the conjugate of the denominator. So the conjugate of 2 minus 5i is 2 plus 5i. But what I do to the numerator, I do to the denominator. All right, I'm going to write, remember, you're multiplying two fractions now. So I'm going to rewrite this as one fraction. So I get 6i times 2 plus 5i divided by, and then these two binomials, 2 minus 5i times 2 plus 5i. Okay, now let's simplify the numerator. So far, if I distribute, I get 6i times 2 is 12i, and then 6i times a positive 5i, so 6 times 5 is 30. I times I is I squared. So that's what I get in the numerator. Now I'm going to simplify this later because I squared we know is negative 1. Now the denominator, let's just go over here and kind of figure that out. So a denominator, when I multiply those two conjugates, remember FOIL, so 2 times 2 is 4, the outer is 10i, the inner is a negative 10i. Remember, since they're conjugates, the outer and the inner better be opposite, so one's positive, one's negative. When we add them up, you get 0. And then the last, a negative 5i times a positive 5i. A negative 5 times a positive 5 is a negative 25. I times I is I squared. So I get 4 minus 25i squared. But I know that I squared is a negative 1. So I get 4 minus 25 times a negative 1. And I know that a negative times a negative is a positive, so a negative 25 times a negative 1 is a positive 25, and so I get 29. So that's your denominator. Now going back right here, I can still go further with this numerator because I know that I squared is a negative 1. So I get 12i plus 30 times a negative 1 divided by 29. And I know that positive 30 times negative 1 is a negative 30. Now we're going to go ahead, remember the directions will say put in standard form. So put in standard form. So I'm going to go ahead and rewrite this as negative 30 plus 12i. So it becomes negative 30 plus 12i divided by 29. And now put in standard form. So write it as two fractions. So it become negative 30 over 29 plus 12i over 29. So that's your answer there. Okay, number 3. All right, suppose we had 2 plus 6i divided by 1 minus 4i. So 2 plus 6i divided by 1 minus 4i. Okay, so again, you want a real number in the denominator. So when you divide complex numbers, the goal, remember, is to get a real number in the denominator. So I need to multiply both numerator and denominator by the conjugate of 1 minus 4i. Well, the conjugate of 1 minus 4i is 1 plus 4i. And what I do to the denominator, I do to the numerator. All right, I'm going to write this as one fraction. So I get 2 plus 6i times 1 plus 4i divided by, and then 1 minus 4i times 1 plus 4i. All right, so I'm going to multiply these out. Now, remember in the previous two, the numerator, we had a monomial times a binomial. So now, in both numerator and the denominator, I'm multiplying binomials. So in both cases, I have to use the FOIL. So let's kind of do the numerator here. So this will be the numerator. So we'll do the work here. So that's 2 plus 6i times 1 plus 4i. So we're going to use the FOIL method. So first times first, so 2 times 1 is 2. The outer is 8i. The inner is 6i. And the last is positive 6i times a positive 4i. So 6 times 4 is 24. And then I times I is I squared. That's what I have so far. Simplifying this, I get 2. 8i and 6i is 14i plus 24, and I squared is a negative 1. So remember that. You have to rewrite I squared as negative 1. So I get 2 plus 14i minus 24, because a positive 24 times a negative 1 is a negative 24. And so my numerator will become 2 and a negative 24 is a negative 22 plus 14i. So that's the numerator. So the numerator is negative 22 plus 14i. So put the numerator in standard form. Okay, now the denominator. The denominator. All right, now remember the denominator, those are conjugates. So remember with conjugates, the outer and the inner will cancel out, and you can end up with just a real number here. So notice in the numerator, I still have a complex number, a plus bi, but in the denominator, I'm going to get a complex number, but it's just a real number. It'll be a real number. There's not going to be an I. It'll be just the real number part. Okay, so I get 1 minus 4i times 1 plus 4i. And so when I use the FOIL method, 1 times 1 is 1. So the first times the first. The outer is a positive 4i. The inner is a negative 4i. And notice those are opposites, so when I add them up, I get 0. And then be careful, because you got to be careful with the last. A negative 4i times a positive 4i. A negative 4 times a positive 4 is a negative 16. I times I is I squared. So I get 1 minus 16i squared. But I know that I squared is a negative 1. So I get 1 minus 16 times a negative 1. And the negative 16 times a negative 1 is a positive 16, which gives me 17. So the denominator is this real number, 17. All right, putting it in standard form, I'm going to get 22 divided by 17, negative 22 divided by 17, plus 14i divided by 17. And so that's your answer. That's your answer in standard form. Okay, and then finally, one more. Let's suppose we had this one. So suppose we had 3 minus I divided by 4 plus 7i. So 3 minus I divided by 4 plus 7i. So again, I'm going to multiply both numerator and denominator by the conjugate of the denominator. Remember, you want to make this denominator a real number. So I'm going to say the conjugate of 4 plus 7i is 4 minus 7i. So what I do to the denominator, I'm going to do to the numerator. And I'm going to rewrite this, since I'm multiplying two fractions, I'm going to rewrite this as one fraction. It will be the first numerator times the second numerator. So 3 minus I times 4 minus 7i. And the denominator, now those are complex conjugates, so I'm going to get 4 plus 7i again times 4 minus 7i. Okay, now let's kind of deal with the numerator. So the numerator, when I do the work here, and then using the FOIL method, 3 times 4 is 12. The outer is a negative 21i. The inner is a negative 4i, because a negative i times a positive 4 is a negative 4i. And the last, a negative times a negative is a positive. I times 7i is 7i squared. Combining like terms and remembering that I squared is a negative 1, I get 12. A negative 21i and a negative 4i is a negative 25i. And then this becomes plus 7 times negative 1. And so I get 12 minus 25i minus 7. A positive 7 times a negative 1 is a negative 7. And so 12 and a negative 7 is 5. So I get 5 minus 25i. So that's the numerator. So my numerator is 5 minus 25i, with the numerator in standard form. So a plus bi. Okay, now when I do the denominator, remember the outer and the inner better cancel, and it better end up with a real number. So there should not be an I in the denominator. So let's do the denominator. So I get 4 plus 7i times 4 minus 7i. So 4 plus 7i times 4 minus 7i. Using FOIL, 4 times 4 is 16. The outer is a negative 28i. The inner is a positive 28i, and that's what we wanted. We wanted these to be opposites, so that when we add them up, we get 0. All right, and the last, a positive 7i times a negative 7i is a negative 28, and then I times I is I squared. And remember, I squared is a negative 1. So this becomes 16 minus 28 times a negative 1. So that becomes 16 plus 28. And then 16 plus 28 is going to be 44. So 44. So I ended up with a real number. So it becomes 44 here. Now putting this in standard form, we get 5 divided by 44 minus 25 divided by 44, I. And so there's your answer. All right, now another way, see how I wrote 25 over 44 times I like this? You could have written it like this, just to show you. 5 divided by 44 minus 25i divided by 44. So you could have put the I in the numerator, but this I should never be in the denominator, because there should not be an I in the denominator. That's a real number. All right, so don't make this look like it's in the denominator. So if you're having difficulty making it look where it's supposed to be, then actually put in the numerator. So either one of those is fine. Okay, so basically what we did here in part 2 was we divided complex numbers, and so to do that we had to multiply both numerator and denominator by the conjugate of the denominator, and sometimes this is referred to as a complex conjugate. And when we did that, we ended up with a real number in the denominator. So the numerator, you still had a complex number with an I, so you had an imaginary number. But the denominator, that complex number here, is just a real number. There was no I. Okay, so that takes care of part 2.